Welcome to APCUG Saturday Safari, where we embark on a journey through the thick jungle of technology jargon, seeking the lost treasured answers to our tech mysteries. We're happy to have you here on a Saturday Safari that we do quarterly for those people who are still working and can't join us on Wednesdays. But we're also glad to see so many of our Wednesday people here. Today we have a very, very interesting, I'm really excited, looking forward to this workshop or presentation. We've heard in the news recently that there's a big thing with the government and their feelings about routers and modems that come from outside the country, and the ban that's being put on them, and a limit on updating. And so today, I'm very happy to welcome Don Arrowsmith, who's president and webmaster for the Philadelphia Area Computer Society, joining us today. Don used his first computer back in 1961, ancient times. And I didn't even know this name, a Bendix G15, which had a whole 2 kilobytes of rotating drum memory. Not a memory chip, a rotating drum. Wow. Don's got a BSEE, that's Bachelor of Science Electrical Engineering, from Lehigh, retired from a U.S. naval facility that used computers to collect data from aircraft engines. Don is the longtime president of Philadelphia Area Computer Society, which has been helping users since 1976. PACAS is a member of the Department of Homeland Security's Stop, Think, Contact campaign, helping to promote cybersecurity and safety at home and in the workplace and in the community. Cybersecurity is a shared responsibility. Visit their website, pacs.org, to learn more about the program. So Don, I'm really excited because I've got a little bit older Wi-Fi router over here that's on the list of companies that are questionable. And when you told us about your workshop or presentation, I'm going, this is great. So I'm going to turn things over to you, and I'm going to take lots of notes, and I've got the video to learn about what I said in the background, securing your home Wi-Fi network with installing your own OS. Great. Done.
I think that's the biggest router I've ever seen. All right, so let me start sharing here. Okay, so thank you for having me, and thanks to everybody that showed up today. I hope that you get something out of it, and I apologize for the clickbait title of this, but as John said, this router ban has been in the news quite a bit. So let's all right. So what's the ban that we're talking about? So in March, the Federal Trade Commission and the FCC announced that there'd be a ban on foreign-made routers that were not already approved by the FCC. So everyone that's for sale at that time had already been approved. And I'll note that most of the routers that are sold in America today, the market leaders, ASUS, TP, Link, they're made in China, not the US, so they would be covered by this ban. In the middle of April, Netgear, which doesn't manufacture in China, but as far as I know, Indonesia, Thailand, and Vietnam, was giving a conditional approval through October 2027. And since then, Eero has been approved until October 31st, 2027. And those will be here before you know it. So, and going beyond just new routers, the FTC and FCC announced that they would not allow firmware upgrades starting, it was supposed to be, I think, March 2027, but that's been extended to January 2029. So, what occurs to me first off is if someone reports a security problem, and let's say in a TP-Link router, and they're a responsible manufacturer, and I know that they have firmware updates periodically. What does that do for people who own TP-Link routers? Does that mean you're going to have to get a new one no later than 2029? And if they are, what are they going to get? So I thought I would just talk about um, what we'll do to keep safe when we're online. And I'll mention that a year ago, the FBI came out with a end of life warning that they have noticed criminal activity on 13 end of life routers from Cisco, Ericsson, Linksys, and probably others. End of life means that they're not supported by their manufacturers anymore, and there won't be any new firmware updates to correct problems. So I had a ASUS router from about 2018, and I loved it. It's an AC86U. It was announced to be at end of life at the end of 2024, and that's when I began looking into, what am I going to do, because I don't want to risk having my information compromised here. I do work for other people, and it would be a problem for a lot of people, not just me. So this is a list of some choices. So maybe you have an ISP router. If you have your ISP is from Xfinity or Fios or another cable company, they provide it. That'll be on them to do something for you. You might have an approved commercial unit now, and hopefully you'll be able to find an approved one. Maybe some of these manufacturers will bring manufacturing back into the US. Who knows? You may be able to replace your firmware in the hardware you have now. Three that I know about are OpenWRT, DDWRT, and Fresh Tomato. And what they do is they replace firmware from the original manufacturer on certain supported devices. And this will be a good time to mention that almost everything that I mentioned in here, a manufacturer or a part number or whatever, I have a link for at the end of the slides. So if you get the material through Judy or through me, you can find out more about any of these. And so these three firmware replacement suggestions that I have, they will have a list of supported hardware, and you can see if you're lucky enough to have a unit that could take this. And the fourth choice would be to get an open source security appliance platform. So I'll call it an appliance platform rather than a router, because in some ways it's not really appropriate to call what you have a router, because I think a routing is the least used function in what you have at home. You have one input, and if it has to go to the internet, you have one output probably. So the route, as far as the router goes, is, comes in here, goes out there. I'll mention many of the other things that your router does, and during the course of this, and you'll see why I like to call it a security appliance platform. Anyway, there's two that I'm familiar with: OpenSense and pfSense, and we'll talk about that a little bit more. Just the spoiler is, I decided to build my own router using OpenSense, and the bulk of this talk today is going to be doing that. So if you have a commercial unit now, you've probably had this drummed into you numerous times. You should do this if you haven't already. Change the default administrative password. This is to get into the management of your router. Change the default Wi-Fi network name and password. Set the strongest encryption available on your device. And really important, to disable remote management if it's available, which would allow someone anywhere on the internet to control your router. It probably came disabled, but it would be good to look at it. And disable universal plug and play and WPS if you have that enabled. And if you haven't checked the router firmware version lately, go back to your manufacturer and see what version is the latest and compare it to what you have and update it if you need to. So if you're going to build your own, these are some benefits that you may or may not get. So you might save money. It used to be the rule that ISPs charge you a monthly rental for the wireless router. That was the case when I bought my ASUS unit. And it was, I think at the time, $10 a month or so. And it was, not too much longer when it would pay for itself. You'll also probably get more control than other routers allow. You can decide what to support and what not to support in many cases. You probably will have more features than other routers make available. And we'll see how extensible OpenSense is. You probably will have better hardware than a commercial unit if you have done the selection of the hardware. They need to be very cost conscious, and you might want to get a better quality SSD or whatever it is. It's possible that you'll have more economical updates if you build your own, and we'll talk about that with my OpenSense as far as Wi-Fi goes. And you'll also probably get security updates more quickly and for a longer period of time than a commercial unit. There was no reason why ASUS had to go end of life on my unit at the end of 2024, except that they are selling new units to people that don't choose to continue running without those upgrades. So as I said, I chose OpenSense. Let's talk about the provenance of OpenSense. So FreeBSD was a Unix derivative. The BSD is University of Berkeley in California, and Monowall was an embedded firewall that was in that. And in 2004, pfSense was forked from that, and pfSense is still a viable product. It's overseen by a company called Netgate. Netgate sells complete systems hardware with pfSense and support for it, but they also make pfSense available for free. So that would be another choice for your own. You don't have to use Netgate hardware. There was some problems that are detailed on the web if you want to look for it between developers, and OpenSense was forked from pfSense in 2015. So OpenSense is overseen by Decisio. It's a Dutch company. And like Netgate, they sell complete systems with support, but they also make this community version available for free open source. Anyway, I'm very happy with it. So you can make your own choice. And if you want to look around on the web, you can find opinions from all different people praising one over the other. I put this quote on here: if you want high customizability and a large support community, pfSense is a good option. If you prioritize on easy to use interface and frequent updates instead, OpenSense might be better. Ultimately, pfSense offers more flexibility for seasoned users, but OpenSense provides a more polished out-of-the-box experience. So in summary, you can't go wrong with either one, but I'm very happy with OpenSense, and the rest of it's going to talk about my OpenSense experience, and maybe you'll decide that's for you too. So, what kind of hardware options do you have if you don't want to buy the complete unit from Decisio? Well, as I said, it's open source. It uses BSD, free BSD as its operating system, and you can use a repurposed desktop PC or a server hardware that you might have around or obtain. Just remember it needs at least 2 network ports, and if your device only has one, it's easy to add a second network card in there. You could put it inside a virtual machine. I know some people do it. To me, it seemed problematic because the virtual machine is on your network, and you're running your router inside this, and if that goes down, you're not going to get to the internet, and it just didn't seem like the best solution to me. Or you could buy a new PC. It doesn't need a big unit because we're not going to be putting in a lot of hard drives and so on. There's lots of small form factor units that you can find at Newegg, Amazon, and so on. What I picked was a small unit from Protectly. They have a good reputation. They're in California, so they're US based, even though the device might be made in China. They have excellent customer service, and they're not the least expensive, but they have good quality components in there. So again, you can find these small units, and they would run OpenSense just fine. I want to keep mine around for a while and not worry about having cheap components in there. So what requirements do you need? So this middle column is the recommended minimum hardware from OpenSense. The third column is what my Protectly unit has. So OpenSense needs a 64-bit, 1.5 gigahertz at least processor. My Protectly, and they have many units. My unit is a V1410. V is for Vault, is the name of their series. It meets that qualification with an Intel Celeron processor. OpenSense recommends 8 gigs of RAM. Protectly has 8 gigs of DDR4 memory. OpenSense wants at least 120 gigabyte solid state drive, and my unit has a 500 gigabyte NVMe solid state drive. As I said before, we need 2 Ethernet ports, one for your LAN side, one for the WAN side. There's 4 ports on my Protectly unit, and we'll talk about what that might be used for later on, but they're Intel 2.5 gigabyte. So I have some room for expansion there, some improvements, because the rest of my network is all 1 gigabyte. Intel usually interfaces usually work well with a lot of different OS things. So I'm glad it has a Intel interface in it. To get OpenSense installed, it's much easier if you have a keyboard, mouse, and monitor on there, although you can run OpenSense headless once it's installed. So if you need to have a port for them, the Vault unit has 4 USB Type A ports and 1 USB Type C port, which you have available for other things later on. And I end up using two of them for other things. We'll talk about that too. Video to plug a monitor in temporarily, at least VGA. The Protectly unit has a HDMI port on it. So I took a picture of one side of it. So if we can get a pointer. Well, hopefully you can see my mouse. So this is a connector for the 12-volt power that's included with it. It's got a long cord. Here are the 4 Ethernet connectors. Here's the USB-C connector. Here's a light, a power light that's green, and this is a red activity light on the storage unit. And while we're here, you can see three little rubber plugs on this side, which allow you to plug in antennas if you're going to put a Wi-Fi unit in it, or if you're going to put an LTE wireless card in it. I have neither of those, so they're not in use. I'll flip it around, and this is the other side, and we can see a recessed reset button, a power button, 4 USB-A connectors, HDMI connector, and there's a slot here for the SIM card if you end up putting the LTE card inside your unit. You can also see that this is air-cooled with a nice heavy aluminum chassis. There's no fan in there, but these are slotted and dissipate a lot of the heat. If we pop the bottom off to look inside, it looks like this. It's only about 6 inches square, 8 inches square, something like that. The storage card would go in here. This is a place for you to plug in the Wi-Fi card if you want to use it in the LTE card. And the rest of it looks pretty standard. You can see the battery for the real-time clock, for example, and so on. So I mentioned that it has 4 network connectors. We could use those extra 2 connectors to make separate physical LANs. If you're somebody that's expecting to use VLANs or virtual LANs, this would be a way to have separate physical LANs. You could use one or both of them as a secondary or a backup WAN if you're rich enough and so on to have 2 ISPs feed your house. We could use it for link aggregation to take those 2.5 gig connectors and put them together to make 5 or 7.5 gig. I don't do that. And again, you can plug in that 4G LTE modem card and use that as a backup WAN. I know T-Mobile has a standby service that you pay $5 a month on, and then you only use it when your main WAN interface connection goes down. You can still get connection. So I mentioned that it's air cooled. I think heat is the enemy of all things electronic, and I like to run things as cool as I can. So I bought a USB fan. You can see the USB connector here. It's a 3-speed fan. It's just about the same size to fit over top of those cooling fins. It's got little rubber feet on both sides, and I just drape it across there, and it lowered the CPU temperatures 10 degrees. So I'm going to tell myself that it's going to make the unit last longer than it would have if it hadn't been there. But I have no reason to believe that it's going to die young if you don't put another fan on. But it was very inexpensively priced, and the USB plugged right in the back, and away we go. So I mentioned that I'm not using the Wi-Fi card. This next slide is a history of Wi-Fi versions. You can see it came out first in 1997. The most widely available now is Wi-Fi 6, which was approved in 2021. As the different generations have come along, their speeds have increased. Wi-Fi 7 is the most recently approved, but it's not really widely available yet. I chose to put an external Wi-Fi access point on there so that if for some reason Wi-Fi 8 is looks pretty darn good here, if I wanted to upgrade to that, I would only have to change my access point and not the router that's inside. And what I chose was a unit from TP-Link. Now, this is not a router, so I don't think this is going to be covered by the ban. It's a Wi-Fi 6 unit. And I just have it sitting out on top. block diagram, it's like this. I have my main OpenSense here, which connects to the internet. This unit is plugged into the main router, generates 2.5 and 5 gig bands for wireless, and then my clients plug into that. So I took a picture of this, and this is the front. There's 4 lights on here. This is a power light, 2.4 network light, 5 gig network light, and a light that says it's connected to the internet. What I imagine they do is they ping something that's on the internet, and if they get a response, they light this light, so you know you have a path through to the internet. Flipping it around, the back has a power switch. Right here, there's a power jack for its power supply. There's one Ethernet jack to plug into my router. There's a reset switch and a WPS switch. So when I bought my own router, I also bought a cable modem. I was on Comcast at the time where we lived until we moved here. And so I was able to bring that along with me. And it's not really germane to today, but this is the unit I have. It's a Motorola MB8600. It's good for up to 1 gigahertz data plan. My Xfinity plan right now is 400 megabits per second. So it's doing fine. It's still supported. And if you choose to do away with paying your cable company, you can buy your own from a list that they show on their website and save that money every month. So I said that on our OpenSense unit, we have one LAN connection, and I have to plug the Wi-Fi into that. So that obviously means I need some way to get extra connections for my wired network. I have most of my devices are wired. We'll look at those later on, but I have 4 8-port switches. 3 of them are these D-Link models. You can see 8 jacks here. If you are familiar with a switch, you just plug your device in and it basically connects them together. But if the first port goes into the router and the last one has to go to another switch, then I only get 6 usable ones out of each one. And this is an unmanaged switch. An unmanaged switch is much, much cheaper. If you think you're going to get into the world of VLANs, you're going to need a managed switch. It's much more expensive. And I had these from my previous setup, so I did not choose to buy new ones. If I do, I'll still think about whether I want to pay for a managed one or not. All right, so to get into OpenSense itself, it comes with FreeBSD, which is a fork off of Unix, as is Linux. And if you have to get down to the command line, although most things you can do right through a web interface, but if you get down to the command line, it would be good to just read the documentation on FreeBSD before you put a command that you may be familiar with Linux in there, because there are some subtle differences in a lot of cases. Some are the same, some of them are slightly different. It also uses ZFS file system. So ZFS file system I am familiar with because I have a TrueNAS file server here, which uses ZFS. With ZFS, their number one priority is data safety, and it uses things like copy on write, journaling, and snapshots. So if you're interested in a really good file system and you have the choice of ZFS, you can do some reading about these features, and you might decide it's for you. OpenSense has complete support for IP version 4 and 6. Comcast supports IP version 6, and so my local network does too. So to install it, as I mentioned, you'll need a keyboard, mouse, and monitor. Uh, you can just borrow them from another system, or maybe you have them in your junk pile. I have tons of monitors around here. And again, once you get it started, you can run it headless because all the management is done through a web page. And if you need to get to the command line, it supports SSH access too. So what you'll do is go to the OpenSense website, download and store the image on a USB drive, plug that USB drive into the back of your whatever your hardware is, boot to that, and then just follow the prompts. I'm not going to go through detailed installation pictures here. You can find excellent tutorials at opensense.org. Protectly, they have some that are applied whether you're using their hardware or not. And on YouTube, there's several, and I have some channels listed at the end. Home Network Guy is one that's especially good. But it's pretty easy to do. And the best thing is when you're finished the install, it's ready to use right away. The defaults that they apply make it so that you could just plug it right in and you're good to go. There's a lot more additional features that are optional, and we'll spend a lot of time with that. But if you just need to replace your router and get it up right and going, it's good right out of the gate. So I mentioned that it has a web dashboard to do management. So you can get that from any browser on your LAN. You can, if you have access to a VPN, so that you can access your home LAN from anywhere on the internet, you can manage this from the internet. It's completely configurable. And what I plan on doing here is when I finish the slides, we'll take some time and go through my live system. But the dashboard has all these widgets on. We can configure it as to which ones are there, which ones are not there, where they're located on there, and how big they are. There's a large number of them that come with OpenSense and are not installed, but it's really easy to put them on there. So if you have other systems in your home lab, like file server or whatever, you're probably familiar with configuration. If you have a router now, you might have saved the configuration. Well, OpenSense, you can back up and restore using a downloadable file. And the thing I love about this is it's an XML format. So XML stands for Extensible Markup Language. HTML, if you're familiar with language for making web pages, is a form of XML. And the key thing about it is it's a regular text file that's in readable English. And so the way I can make good use of this is, let's suppose I want to make some changes and I'm not 100% sure about it. I've seen a couple of videos on YouTube, but I'm a little nervous. So I can download a configuration before I start, do my work, download the configuration afterwards, and then I can use a program to compare these two files, which are just text files. I use a program called WinMerge, which is excellent. It's free on my Windows system. And that will show you the exact changes between before and after. And so you can see what got done. If you've made a typo in there, you can easily see it. And if you are unhappy with what you did for one reason or another, maybe it just wasn't to your liking, or you made a really bad mistake in there, you can use that downloadable file that you took before, restore that, and it's like you never did anything to it. You can also keep a current copy of the configuration so that if your unit dies for whatever reason, maybe you used an older PC and it gave up the ghost, you can replace that with something else, do the install as you did before, restore using that file, and you'll have an exact copy of OpenSense. I mentioned snapshots as a feature of ZFS. This is a way to get an exact copy of the file system that's on that pool. So in my particular unit, there's only one SSD in there, so the pool is only one drive. But you can take a snapshot, and it will copy all the which files are in use and where they are, and you can use that to go back to a previous situation. So again, if you try something and it's just not right, if you have taken a snapshot before you made a change, you can go back and reboot into that snapshot, and it's just like the bad stuff never happened. You can pick which one to boot into using the OpenSense GUI. You can also select it from just booting it up with, if you go back and put your keyboard on there and a monitor, you can just select it right at that point too. So another thing that OpenSense includes are cron jobs. So it has a large library of pre-configured jobs. So cron jobs are things, usually command batch files that you can run at particular times to do particular things. You can make up your own in addition to using one from this library. Their GUI lets you pick one and set up the timing. I have two in place now. One is to scrub the ZFS pool. So scrubbing means in ZFS world, reading every clock that is in use at that present time. So it will find any hardware errors that you might have on your storage device. And the second one I have is to use a trim command. Trim with SSD takes blocks that were deleted and puts them back into the free block pool. So this is something that happens on the device and not in the file system. And I run each of these, I think, once a month. So trim, you should enable trim on whatever system you have that uses SSD storage on there, because it will lengthen your SSD's life by returning blocks that you're not using anymore to blocks that are available for future use. So I mentioned that a router doesn't do much routing. Maybe the most important thing it does is become a DHCP server. So DHCP is Dynamic Host Control Protocol, and it's the way that devices get to play on your network. When you plug one in, back in the early 90s, 80s, we had to go through and configure the IP address, the DNS server, the gateway address, how many bits were on your network manually. But I think everything today just uses DHCP. You plug a new device in, we're connected over Wi-Fi, and it says, "Hi, can I play on your network?" And it says, "Sure. Here, use this address. This is what gateway you'll use. This is what the network looks like." You can put other things in there, like this is the DNS server that you should use. This is the network time server you should use, and so on. So this is a pretty important part. This one has, OpenSense has three choices on there: ISC, Kia, and DNS mask. So ISC is the original DHCP server. It's from the Internet Systems Consortium. That version is end of life now, but since so many people were using it, it's still available on current OpenSense. Kia, which if you want to impress your people at the next bar, Kia is a New Zealand Parrot, and it was the code name for the successor to ISC DHCP. That's one that's, I think that's the default that comes out of the box. And then DNS mask is another choice. I'm using DNS mask. All three of those can support DHCP reservations. So DHCP reservations have a table in there of MAC addresses, which is that 12 character long string that is supposedly unique for every device that will hook up to the Ethernet. And for each of those separate MAC addresses, it will assign an IP address for it. So this way, the DHCP server doesn't give out a random address to your devices, but they'll always get the same address, which for me makes troubleshooting easier, because if I look at a dump of something and see the IP address, I know what it is offhand. I know that dot 5 and dot 6 are my Raspberry Pis, dot 2 is my HP printer, dot 103 is my main unit, dot 152 is my main file server, and so on. So they're not required, but they're supported if you want to use it. There's extensive logging on not only DHCP, but everything else too in OpenSense. And it supports a DHCP server for IP version 6. There's an NTP server in there, which is network time server. You can choose the upstream time servers, and you can specify each of those servers' domain name. Again, it has logging, and then you can use that. You can use the IP address of your OpenSense to tell your devices on your LAN what they should use for NTP, and then all your devices will be synchronized. It includes a recursive domain name server. So you can avoid your ISP servers by having a domain name server of your own. That way they can't collect who you visit and then sell your data to other people. There's a lot of public resolvers available that might do the same thing, but if you want to have it really your own, you can put it on your OpenSense or whatever you use, pfSense. If you want to find out which upstream server is best for you, I'll put a plug in for a DNS server speed benchmark you can get at grc.com. And like I mentioned before, the link to this will be at the back. And you can tell which server would be the fastest for you, because every time you go to a web page, it's got to resolve that domain name into an IP address. So the quicker you can make that, the quicker your web pages are going to come up. So on the OpenSense recursive server, you can specify a different server for your LAN host. I run Pi-hole, which is an ad blocker. I have two of them, primary and secondary. I have them running on bare metal Raspberry Pis, which are on my network. And all my LAN devices use this for essentially blocking ads. My wife is not techie, but and so many of the things that I do, I never hear. Well, I hear if they're bad, but I don't hear if they're good. But as soon as I put the Pi-hole on there, she said, "What did you do?" My New Yorker and New York Times are so much better now. None of the ads show up, and so if you want to impress your spouse, think about a Pi-hole. And again, this domain name server on OpenSense will include anything you put in as a DHCP reservation, so you can refer to your devices on your LAN by name. So security-wise, the most important thing for your firewall appliance your whatever I called it, is firewall and an inbound and outbound. The default rules, as I mentioned, are excellent. You can find other rules and tutorials for writing rules on the internet. The WAN input rule, for example, blocks everything so that if you have something on your network that you've misconfigured maybe and you don't want anybody to access it, it won't, by default, it won't be available on the internet. The rules, you have extensive choices for interfaces and direction and logging, whatever you come up with. And if you're using anything as a router now, I'll put another plugin for grc.com Shields Up free app that will go through and test for open ports. And if you find an open port that you weren't expecting, then you can take steps to close that off. OpenSense uses geofencing. It has arrangements with two suppliers, IPinfo and MaxMind. And what geofencing can do is, among other things, ban access from particular countries. And we'll see that when I get to my unit. Of course, since you only get one address to your router from your ISP, your router needs to do network address translation so that you can share the various devices on your network with the one address that you have to get out to the internet. And OpenSense just handles that automatically. I mentioned VPNs before. If you go to the coffee shop with your laptop, you're much safer if you can use a VPN. There's a lot of commercial VPNs available. OpenSense has four VPN solutions built in. So OpenVPN is available. It's widely supported. It's been around for a long time. If you set up an OpenVPN server on your OpenSense and then put an OpenVPN client on your laptop or your smartphone or your whatever, you can connect back into your OpenSense router, and you can have configured that to either, from that point, either only let you get out to the internet and go to your devices on your LAN. So you could go to the coffee shop and print on your local printer if you've configured it that way. But if you're going to the internet from the coffee shop, then you won't have to worry about any man-in-the-middle attacks or anything else that people have found at the common public Wi-Fi. Second choice is WireGuard. WireGuard is newer than OpenVPN. It supposedly makes its connections faster with a higher throughput and more security. I have both of them set up both on OpenSense and on my devices. I haven't made a decision yet on whether one is better than the other. OpenSense has IPsec available too. I have never used that, so I can't comment on it. But you can use Tailscale, which is a peer-to-peer mesh VPN. And if you have a system, if you use an ISP that uses CGNAT, CGNAT is carrier grade NAT. So CGNAT is like NAT for ISPs that let them share clients over a limited number of IP addresses that they have procured. So we all know that IP4 is out of addresses. You may be given an address that is going to end up using CGNAT, and that CGNAT causes a problem with OpenVPN and WireGuard, but Tailscale gets around it by using a third party to have both your clients and the server connect to that, and then function the same way as the other VPNs. There's logging, there's dashboard widgets for those VPNs. And as I said, you have a lot of configuration choices. If you're going to use OpenVPN or WireGuard and you do not have CGNAT, somehow that client has to find you. And your ISP can give you I'm just looking at the time here. Hope John is up for giving Overlord. Um, they have to be able to find you. So if your ISP varies your IP and they don't guarantee a static one, static IPs are sold to um, business accounts basically, and they're much more expensive. But DDNS is a solution for that. So you sign up for a free DDNS service. I've listed two of them here. And then your Open Sense will tell that service what your current IP address is. That service provides a domain name that's available to DNS system, and your clients in the coffee shop can use that to get to your home address, even though your home address might be different between today and tomorrow and next week. So DDNS services, there's a large number of them that are pre-configured in OpenSense, and there's no limit on the number that you can have. You really only need one. You might be OCD and have more. I'll confess I have 5. There's a reason for it, but that's not today's topic. You can get an SSL certificate to access your dashboard. And what that lets you do is when you get access to it, your browser will show secure access and not insecure. There's a easy way to get this free certificate on OpenSense, and it makes you feel better. And that also sets up a cron job that will renew that certificate when it needs renewal every 90 days, or I think they're going to 45 days soon. CrowdSec is a crowdsourced list of bad IPs that people have reported. And the CrowdSec app that runs on OpenSense will generate firewall rules that will keep any of these bad IPs from accessing your network. HW Probe is another optional plugin. It'll generate a complete list of your hardware and upload it to this website, provide a link to that report, then make that available to you for help and troubleshooting. So if you have a really sticky hardware problem or software problem, somebody wants to know your hardware, you can send them this link and then they can see a detailed link of your hardware. It's basically linked for FreeBSD installations, but since OpenSense runs on FreeBSD, it applies here too. Monitor is an app that will monitor various conditions or a batch file maybe that you wrote, and then email reports to you of problems or just alerts. So I have one set up that when it sees a new firmware version for OpenSense, it'll send me an email. Now I could see that that's available by just going to the dashboard, but I have to actively do that. And using Monit lets it push that email to me. And so I know as soon as that's available. And TOPNG provides really extensive reports of traffic on your router. I wasn't getting much use out of it. I set it up and then I've removed it. It's writing to a database, and all those writes to your SSD, I imagine, can reduce device life. OpenSense supports Smart for your SSD. You can run it on demand or be scheduled to monitor the SSD health, and there's a widget for that and shows up on the dashboard. Network UPS tools. So you should have anything that's important protected with a UPS. It filters out surges and spikes, and it provides a limited amount of time from its internal battery if you lose power altogether. Certainly enough time to do a graceful shutdown. And what NUT does is interface with a UPS, because most UPSs only have one monitor port. And if you have OpenSense plus a file server plus Raspberry Pi plus another Raspberry Pi, et cetera, you'd only have one place to plug that in. What NUT does is it's available in a server mode and client mode. You can put the client on these other devices and put the server app on one device. I put it on OpenSense, and then it echoes the alerts from the UPS out to my other devices and tells it when we go on battery power, how many minutes we have left. If we're getting down to the end, then it'll tell them, and the different devices will be able to do a graceful shutdown on their own. So if you're not home, power goes out from a thunderstorm, it could keep you from having a problem. Raspberry Pis, I'll mention, typically have trouble with just having the power yanked away from them. So some extra features. I mentioned virtual LANs, VLANs. A lot of people like to segment their devices on their LAN to keep them isolated from their man LAN and Internet of Things LAN for things like door locks and cameras, security cameras, and so on, and to provide a guest LAN for people that maybe come over for a LAN party or something. There's intrusion detection system and intrusion protection system plugins for both Suricata and ZenArmor. Some people you like to use these. You can use both of them. Some people use one on their LAN side, one on their WAN side. I tried them. They didn't seem to be giving me added value, and so I stopped using them. And of course, I mentioned logs and reporting on all kinds of things, devices, directions, protocols, and so on. So that's the balance of the slides, and I'm going to just run through the next few, which are links to pretty much everything that I've talked about in here. And if you want more information about it and you can't remember, you could either Google it or go to these pages and see get the URLs directly. I also have a list here of channels on YouTube that are particularly oriented towards OpenSense. And these are understandable and extensive, and I got a lot out of them. So at this point, I'm going to stop sharing this, and I'm going to go and share. Well, let's go back to this again. And let me get to my device. Hopefully everything will work out nice. It'll be well behaved. Okay, so I have RoboForm as a password manager, and here we are. Can everybody see my dashboard here for OpenSense?
Yes, we can.
Good, thank you, John. So there's a navigation on the left here for a lot of different categories. And this little pencil here lets you edit this. As I said, you can add, subtract any of these widgets. Let me just click that, and you'll see that at this point, I can add a widget, and it will give me a long list of widgets that I do not have in here. Maybe I'll put them in later, who knows? And you can rearrange them. You can make them bigger. You can do all kinds of things. So system information, this is the version of OpenSense that we're running right now. Here's a little diagram of the load on my Intel Celeron CPU. These are the interfaces and what they're hooked up to, my WAN side, my LAN side, and it also shows my open VPN and WireGuard VPN addresses. Here's the two gateways, my WAN side IP version 4, my WAN side IP version 6. An easy way to look at how many bytes are coming in and out on both the WAN side and the LAN side. A quick look at firewall states, how many I'm using, memory, disk, and on the swap file. Here's traffic in and out on the LAN side and the WAN side. It's live, as you can see. Down here, these are all the services. If they're stopped, this will be red, and it gives me a chance to restart them. This is the NUT package I was talking about. This is connected to my APC UPS. Quickly, it shows that it's the battery in there is charged to 100%, and it thinks that it can run for 24 minutes and power everything that's connected to it. And right now I have my main Windows 11 PC, OpenSense, one Raspberry Pi, my Wi-Fi access point, my internet phone, and a couple of switches. I think that's all. So it thinks that it can run for 25 minutes or so with that. And when it gets down to about 10%, it'll tell the other devices that need to have graceful shutdowns to shut down. In this case, it'll be my Windows 11 machine and my Raspberry Pi. And once those two are shut down, OpenSense will shut down. This is the smart status, just a summary that it's okay. That's good to know. If there was a new version of the firmware, it would show up right here under announcements. The business edition of OpenSense is what they sell to their enterprise customers. This is what I'm using, and this is what I have. 26.1.8_5 was from 13 May, and there's no new one since then. These are the certificates in there. The OpenSense certificate here is used for the accessing this page, and you can see up here in the corner, it's showing as secure, and it's going to be renewed shortly. It's down to 11 days. Other certificates, the firewall, kind of a summary of what's going in and out, and then WireGuard and OpenVM, VPN, what's happening there. None of those are connected right now. So let's see, what else? Configuration, right here, backups. So this is where I would do a backup here, download it, and I encourage you to, make good use of that. There's a history, and it shows changes right here between different ones, but it's a little hard to read, and that's why I recommended an external one. Let's see, firmware status. So firmware status. This is where I would do a check for updates, especially if I knew that one was available. If I click this, it'll come back and either say yes or no and let me update it. If I look at changelog, these are the updates that it's made. This is the one that's currently using. I previously updated it on April the 30th and April the 9th and so on. You can see there's generally about 2 a month that come out. They're very good about updating OpenSense, and all the they'll do updates when there's packages that they depend on. Let's see, plugins. These are other plugins that are in bolded, are installed, And the other ones are ones that are not installed but are available. And I can click this plus side over here to install it. So I mentioned some that ISC DHCP that's been moved to a plugin status. It's right here. If I wanted to continue using it, I could click the plus and continue to use that. Let's see, settings. Cron. These are the cron jobs that are running. Most of these in OpenSense have enablement boxes. There's one that's not enabled. Here are the two that I added, one to scrub the ZFS pool and one to trim the ZFS pool. And it shows you the when it's scheduled to run at 30 minutes after midnight on the first of the month, 30 minutes after midnight on the 15th of the month. Do that every month, no matter what day of the week it is. Snapshots. Okay, these are snapshots that I've made, and you can call them anything you want. Again, I can add one by clicking this plus sign in the corner, and you can give it a name. I mentioned that I do it before I do an upgrade, and then I know what I can go back to. So this was done just before I did the upgrade to 27.8_5. If I'm disappointed or it doesn't work for some reason, I can go back to this, and there we are. See, firewall. There's a thing called aliases, which let it define groups of different things and make it easier to do the firewall rules. Now you'll see right here, these are ones that I've added. Block China, Iran, North Korea, and Russia. And again, there's enable or disable here. If I uncheck this, it'll let Russian things come in and so on. You can follow through with this and see what it gets used for. We're going to look at a log file in a minute and see these in action. So rules, these are the rules that are in there. These little icons say whether they're going in or coming out, whether they're to pass the traffic or block the traffic, whether it's on an interface or whether it's a group, and so on. So this rule was to let OpenVPN traffic come in. Some of these are made up automatically, and some I've added for one reason or another. So let's go down to log files here, and we're going to look at live view. Again, this is a live view of what it's doing, the firewall is doing. If I go to this choose template and say, show me the ones that are blocked countries, this is, I think in the last hour, we've had all of these accesses from China. So what are they trying to do? So here is my IP address right here, and they're trying to access port 22, which I think is, it's either SSH or it's Telnet. And we don't want them to do that. This is a new one that just came in. This is my address. It's an ICMP protocol. They're just pinging it to basically see if I'm there. I don't recognize any of these other ports. Port 853 might be a particularly well-known port for some product that maybe enterprises use. I've seen that, but again, they're blocked, so they're not getting anywhere into my LAN. VPN. Okay, VPN. You can see the three basic ones that are built in. I have an instance here. You can configure it using this. I have in WireGuard, I have one instance of this, and with WireGuard, you have to define the peers. And these are the devices that will connect to my WireGuard instance. My phone is a OnePlus 13. My OnePlus Pad tablet, my wife's iPhone 11, my wife's iPad Air, and my HP laptop. So those are the only peers that can connect to my WireGuard instance. All right, let me move down to services. Acme Client is one that I added. And this will show you the log of accesses for it. If you want to set things up, you can go here and the schedule and so on. There's too much to just go into everything here. But if we were to go to services, CrowdSec, alerts, these are things that CrowdSec has reported that this IP address was on their list of bad IP addresses, and it's going to ban it. Now, we might have looked at the IP address on those accesses from China and reported them, and maybe they would make it onto the ban list. And then this would be another way to not only keep them from coming to my unit, but anybody else that was using CrowdSec. Let's go down to network time and status. And you can see what it's been doing. It's you have to read some more about network time to know it, but there's a pool here, an OpenSense pool, and it's using 4 of those servers, and that's probably where it's getting its time from. So it's pretty accurate time. NUT is for the UPS. If we went to diagnostics, this just did a poll out to the UPS unit, and you can see what the UPS is reporting back. This is the manufacturer, the model number, when it was manufactured, how the battery charge, the low point, when the warning point is, and so on. The input voltage coming in, when it should transfer over. If it gets to over 144 volts, switch over to battery. If it goes under 88, switch over. It's coming in at 124, and so on. Let's see, finally smart. So smart, this is a way that we can tell it to do a self-test. We can do short or long smart test. We can do it whenever we push that button. I'm not going to do it now, but you have a lot of control over that. And then help, here's links to documentation. They have an extensive user forum. And if you are an enterprise unit with paid support, you can use this, and you can call them, I guess. So with that, I think I'm done. And if you have any questions, hopefully you've sent them to Judy, and she's going to relay them to me. So thank you.
Very good presentation. I thought after having built computers by themselves, and I built 3 of them for myself, that there were no more projects to do. This one looks like a really great project, but I'm going to have to wait until my grandsons are gone because school's out and I've got them most of the summer.
Any questions?
Judy's kind of pulling things together. We'll see what she's got.
I have one question. My gosh, that was so comprehensive. It's incredible. Richard would like to know, where is the DCHP coming from?
OpenSense is serving as the DHP server. So when I plug a laptop into a jack on my wired network or hook it up to my Wi-Fi, when that starts, it wants to get access to the network, and it sends out a DHCP request. Any DHCP servers on your network then reply. It picks with a suggestion. It picks one of them and then says, "Okay, I'll take yours." I only have the one server running, and so that's the one that it takes.
Outstanding presentation. Way cool. And I'm hoping that you will think about giving some more presentations. I'll just say that out loud.
Well,
Like
this isn't my first.
one I know on Raspberry Pi. I still want somebody to give one on Raspberry Pi. We had one years ago, but it just sounds way cool.
Well, they are cool.
So over to you, John.
Okay, I would like to thank Don for sharing with us today and giving us an option.
Well,
Yep. He's unsure. Give us an option of what to do about routers, and then connecting a Wi-Fi hotspot, or not a hotspot, the other part to connect for your Wi-Fi.